Hello, and thank you for joining us in this fourth forum of the day, coming out of the Neuroverse. This one, Have the Robot Armies Arrived? I'm Kay Maslot, Founding Director of Media Art Exploration, and I want to welcome you to this fourth forum of the day from the Neuroverse. We presented 3 days of live arts performances and immersive experiences. We slipped it in between variants of the COVID virus, and we were delighted to have these artists present this magnificent work to full houses and very exuberant audiences. If you hope that we will all be together much more often in the near future, fingers crossed. At Max, we both harness and interrogate the scientific and technological advances of our times. Moving into the Neuroverse, we had an artist with whom we attempted to collaborate with a robot related to ones you will see in an upcoming video. Unfortunately, that robot's keepers decided not to let them come to play with Max. So we couldn't harness or collaborate with this robot. So we wanted to take this opportunity to explore where these robots are headed. Have the robot armies arrived? From an open letter by AI and robotics researchers spearheaded by MIT professor Max Tegmark, I quote, "Autonomous weapons are ideal for tasks such as assassinations, destabilizing nations, subduing populations, and selectively killing a particular ethnic group. We therefore believe that a military AI arms race would not be beneficial for humanity. There are many ways in which AI can make battlefields safer for humans, especially civilians, without creating new tools for killing people." Unquote. Every science advisor that Max has reiterates, it's not what the machines will do to us, but how we instruct the machines. Some, like the group quoted earlier, believe we are at a crossroads. So we have asked Professor of AI and Ethics, Law Professor Ryan Kalo from the University of Washington to talk with Max thought partner Adora Udoji today and explore this question of where is AI, and to hopefully avoid this path to the apocalypse and take another fork in the road. So they'll help us explore where we are and what decisions we can make to avoid the wrong path. So thank you for joining me. And before I hand it over to Adora, I want to acknowledge that we post these forums from the unceded territories of the Lenape people. Thank you all for joining us for these forums. If you haven't seen the 3 earlier forums from today, please go on our YouTube. In those, you will hear from the artists and thinkers involved in the festival, the Neuroverse, and hopefully you will check out our website for excerpts of their work. And we have strong feelings and reasons to believe much of that work will show up in your hometown. So we look forward to having you as a Max partner, and please be in touch with what you think of the forums and our work in general. Thank you for coming.
Hi there, Professor. How are you?
Hello there. How you doing? And
I'm
please,
good.
Ryan, of course. Please use Ryan.
Oh, you Ryan? I will absolutely do that. Well, listen, I feel like I could watch that video over and over again, like all day long, because I'm equal parts exhilarated and inspired by the genius of the software, the hardware, the creativity involved in just creating something that mimics a human being. and I'm equally like horrified because they look like soldiers to me.
Absolutely. Absolutely. I mean, I cannot emphasize enough what an engineering marvel that is. I mean, just the way that they're having to integrate multiple sensors and coordinate any number of actuators to mimic those movements. I mean, you think of just a couple of years ago when DARPA, you know, the defense research arm, held a competition for folks to build robots that did a variety of tasks, and just how poor they were at it just a couple of years ago. And then to see that it is a sea change in robotics, absolutely, and a marvel to behold.
It's really 100-year or more in the making. I mean, these things are not overnight success. I mean, there's been tens of thousands of scientists, technologists, designers who've been working on these things for years. But let's talk about this idea of have the robots arrived. And let's talk about it with the lens of both how it impacts us at home potentially, as well as how it might impact global warfare, for example. That example of robots that we just witnessed, they do look threatening and they do look like soldiers. And is it possible, from your understanding, that today there could be armies of those, there could be hundreds of those that are sent out with particular tasks, whether it's shooting or taking on certain actions that would be related to active warfare? Is that possible?
Yeah, Adora, that is conceivable, but as you alluded to just a moment ago, this has been long in the making. I mean, one of the ways that I wound up getting into robotics, you know, being a law professor, of course, was in reading P.W. Singer's 2008, 2009 book, Wired for War, where he detailed just the robotization, basically, of the military and what was underway. And we are, of course, now decades into that automation. You know, it's conceivable. I think the more plausible, at least short-term scenario involves co-robotics. So that would be soldiers working together with the PackBot, which they already do from iRobot.
What was that you said?
The PackBot. So the folks that make your Roomba that you like so much, and that cleans your floor or your pool. Cleaner. Yeah, exactly. They also have long made a military robot that helps with diffusing bombs or reconnaissance or what have you. And so I think that the immediate future is one of co-robotics, where soldiers work alongside robots with different, what we call morphologies, meaning different design aspects, whether they might mimic a person, the way we saw with I believe that's an Atlas, or versus a Spot, which looks like a dog, versus a PackBot, which doesn't look like either one. But conceivably, yes, conceivably in the sort of not too distant future, you could imagine deploying robots like that in the theater of war.
I guess my question would be, just as we say on the technical side, and we'll move to other questions around applications and regulation. But in terms of the technology, I've done a lot of work in AI, and we're a long way from being able to develop software that can think like humans. We can design artificial intelligence, which is the big umbrella of a long list of types of advanced algorithms, where we are asking computers to perform certain types of tasks. So if people are thinking about them as actual autonomous beings that are out in warfare making decisions as they're going, I think we're far away from that. Like we are very far away. But as you said, it's a continuum of automation all the way through to these robots, right? So we can talk about what are drones up to these days. We consider those robots too, right? I think, and you alluded to the fact that we've had some recent news about what have drones been out there doing, working with humans.
Indeed. I mean, I think it's important for the public who watch these videos to understand that an enormous amount of effort went into orchestrating that particular sequence. I like to say that for every one of those, you could have a couple of at least a few PhD candidates get dissertations based on the work that goes into that, right? If you were to instead take that robot and try to send it to the store to buy you a 6-pack of root beer, right? That would be a whole other thing, right? That would take a long, long time to orchestrate. And so there's a ton behind it, because robotics is fundamentally very, very hard. It's hard both because artificial intelligence is difficult and probably best understood as a set of techniques that are aimed at approximating some aspect of human or animal cognition, and coming up with a system that's able to operate freely in the world with all of the different variables and all the different conditions is extraordinarily difficult. And it's also hard because, robots in particular are these physically embodied machines who have to go into a real world that has dynamic conditions and the like. And so it's important to understand.
So in other words, apologies for interrupting, but in other words, it turns out the human brain is really complex, and the human brain and body together are incredibly complex and incredibly difficult to emulate through just pure software and hardware.
Absolutely. I mean, if you think about it, even if so, first of all, the billions and billions of connections in our brains, and the way that our brains have evolved. I mean, for what we do, for the process of constituting reality, it's incredible amount of computation. So you'd have to imagine a huge leap in just the pure computational power. Think quantum computing. That's like. But not only would you have to come up with extraordinarily powerful computers, you'd have to write software on the level of a Mozart, right? Before you could purport to emulate the kind of consciousness that arises, in a 3 or a 4-year-old. It's a marvelous test, yeah.
But however, right now, today, automated designs of hardware are being used to facilitate warfare.
Absolutely.
When I alluded to this idea, I mean, drones have been in operation, and even within the past couple of weeks, as you were just saying to me, that they're being used to try to assassinate world leaders. Could you speak a little bit about, from your seat, where we are today and how robots are being used in that capacity? Quote unquote robots are being used in the capacity of armies and warfare.
Right. I mean, I think I would just sort of draw a distinction in all of our minds between the idea of creating a system that's capable of going out in the world and navigating it autonomously and making decisions, right, versus telepresence. Telepresence is the ability to project human will and activity at a distance, right? So this might be an undersea robot that is working in salvaging a shipwreck, or it might be a drone that is being operated in the theater of war, say in Iraq or in Afghanistan, from Arizona or Florida, right? And so the idea to be able to project machines at a distance and project human will, that's been largely the use case of military robots. Now, there is some autonomy involved. I mean, if you think, for example, about the Mars rover does have some onboard capability, and it needs to have that in order to navigate the local Mars environment. But for most part, the instructions are coming, have been coming from NASA. Similarly, while military drones do have autonomous settings and they can even return back to a beacon and things like that on their own, they're really being remotely piloted by soldiers. And so the thing that's been amazing to me, Adora, over the years is to watch that go from being a military technology of which only the United States and a handful of other countries are capable of creating, to being something that's so democratized that rebels or insurgents or whomever are able to use those same kind of tools. And in fact, there was just an attempt on the leader of Iraq the other day using multiple drones in order to attempt to take his life, which was not successful. There's also been similar instances in Iran. But what I think probably everyone is familiar with is the routine use of drone strikes by the U.S. military in the theater of war. And again, it's not the robots making the decision. It's people making the decision. But still, it's an incredible power to be able to project at that distance.
So we're really talking about a continuum, right? There's a continuum of what's possible today, and then what the aspiration might be. And some of that aspiration might be represented by what we see with Boston Dynamics, right?
I think that's absolutely fair. Yeah.
When we get to the point where those robots, it's not inconceivable that we're going to get to a point where those robots are able to autonomously go out and do a lot of things and cause a lot of destruction, because we can only imagine how powerful even one of them might be.
Absolutely. I mean, you know, at some point, I do think that the dream is to have as little human involvement and therefore as little risk to one's own soldiers and own military as possible. I mean, the use cases that I hear about are not necessarily single humanoid robots like the one we saw, but actually large swarms of smaller robots, maybe deployed from the sea into the air, for example, that work in a coordinated fashion in order to do reconnaissance and also to take out targets. But it's a continuum. I mean, the thing about robots is, you know, robots have been around for a very long time, right? There are references to them in classical antiquity, right? But somehow they always seem to be heralds of the future. Right, so they're this old technology that always heralds the future, right? And that's what's been fascinating about them to me, right? It's just like they're always the signal of what's to come, though they've been around with us for many hundreds of years.
So they're getting more sophisticated for sure. And you talked about a very specific application today around drones. And of course, this triggers all sorts of ethical, moral, and policy questions. So let's talk about what's happening in those realms. What's happening in the courts? Is this issue, has it made it to the courts? Are there instances where we've seen legislatures or policymakers anywhere in the world really try to regulate any of these applications or the devices themselves? How might we be thinking about what happens as they continually grow, become more sophisticated, and could potentially do more harm than good, arguably?
Sure. I mean, there are innumerate efforts underway to try to figure out how best to do governance of artificial intelligence and robotics. Right? They tend to be relatively context specific, but I'll give you a few counterexamples. One of them is that the military, our own military, United States and other militaries around the world, are convening to talk about the importance of maintaining meaningful human control in kill decisions, for example, right? And that is an ongoing debate. And in theory, it could be enshrined into convention, into law through treaty. Then you have large scale efforts like the efforts in Europe right now and within the European Commission to come up with an actual Europe-wide directive, or EU-wide, I should say, directive on artificial intelligence, and sort of what would that look like? And that's being debated, all the way down to individual US states, which have been passing robot-related laws for like 15 years now, right? Sometimes
give us some examples. What are they? Yeah, what are they legislating or trying to?
Yeah, sure. So you know, first of all, the initial wave was really driverless cars and domestic use of drones. Okay, so with driverless cars, you had really the story starts, you know, years ago now with Nevada, and Nevada wanting to be a state where they were thought of as being innovative and they were the next wave of innovation. And Google comes to them and says, if you want to be innovative and you want to attract jobs, you should really pass a law in Nevada about driverless cars, okay? And here's how driverless cars work, and this is what Google wants to do, and others will too, and you should pass this law. And the Nevada legislature says, yeah, that sounds great. So what they do is they end up passing a law that defines artificial intelligence and defines autonomous vehicles in a way quite specific to what Google was doing. as, you know, sort of, I'm paraphrasing, but any time that the car, the machine, substitutes for what the driver would do. Okay, but this illustrates some of the classic kind of blunders that you can run into when it comes to regulating something like robotics. You know, all these other established car companies already had these technologies that were on the continuum, right? And so, you know, Lexus comes to the table, you know, BMW comes to the table and says things like, wait, I'm sorry, are you serious? So this law applies to my car that I've been selling in Nevada already, that does adaptive cruise control or can park itself? All of a sudden, do I have to have a special, you see what I mean? And so leading the state of Nevada to cross out its definite, I mean, the very first law to define artificial intelligence in America had to be repealed and then rewritten a year later, right? And part of the issue there was you know, just basically listening to one version of a technology. It is a tendency that we have as policymakers, that lawmakers tend to have, and the public too, is to accept things that are actually deeply contingent as though they were inevitable or this was the only possible instantiation of them. And so rather than think about what are the affordances of artificial intelligence, these sensors, these processors, how could they change mobility? How could they change transportation? Nevada decided to enshrine a particular vision of driverless cars that was told to it by a Google lobbyist. And unfortunately, this is a pattern that is recurrent. And I can tell the same story about about delivery, using delivery robots, or about drones.
I mean, I think there's a couple of thoughts. I mean, I could probably talk to you all day long, but the first one is, what the hell is a robot? It's like, we almost need some kind of definition, right? I don't even really know what is a robot, right? Is that Roomba, the vacuum cleaner that moves around my apartment, is that technically a robot? Autonomous vehicles, is that a robot? Does it matter like how many advanced algorithms that you're using in that particular device, or multiple devices that are connected in some way? Is this what makes it so challenging? Because to be honest with you, I don't think if you got 100 computer scientists, PhDs, nanotechnologists all in a room and you ask them to define what artificial intelligence is, I don't think they would come up with the exact same wording.
I don't think so either. I mean, one time a grad student and I, she's now a postdoc at Cornell, Meg Young, we looked at how different disciplines define the word robot. And one of the things that we found that was so fascinating was that different academic disciplines will define robot differently based on what they're interested in. So for example, if you're in the humanities, you might define a robot as an artificial person, and therefore it would be in the same category as Frankenstein, or, you know what I mean, or a zombie, or a golem, right? Whereas if you're in electrical engineering, you define robot as a programmable machine. Why? To differentiate it from a dishwasher that only does one thing. But the definition that I use and I like is from computer science, and it's something called the sense, think, act paradigm. And the idea is that you can distinguish robots from previous and constituent technologies by reference to the fact that they can sense the world around them, process what they sense, and then act upon the world. And this is an old psychology paradigm applied to people that has been repurposed for robotics largely by the computer science community. But all these things exist, again, as you put it before, in a continuum, in a spectrum. You can have things that have relatively little capacity to process, but they have some, and you still want to call them a robot. The Mars robot, we want to call it a robot, even though it's not capable of getting itself to Mars and navigating that environment and doing scientific experiments without an enormous amount of support and instruction from NASA.
So there's lots of different layers here, and I guess that sounds troubling that legislators, who many are not experts in any of the attending disciplines, are trying to define something that is also changing all the time, right? I mean, what we just watched with Boston Dynamics, that was not possible 5 years ago. The videos that they were putting out a couple of years ago did not show individual robots that were built like humans that could move as seamlessly as those were moving. So it's constantly changing also. So how do we even start thinking about this before we get to the point where these machines are being asked to make decisions about whether or not to shoot someone or any other type of decision that could result in real damage to human beings or property or the world?
Right. I mean, I think that the way to think about this is that law regulates human behavior. It regulates what we do with things. And that you really should be thinking the way that I approach robotics and the way I approach law and technology generally is I ask myself, like, what are the new how does this technology change human affordances? Like, what can we do that we couldn't do before? What do we do differently? And courts have already struggled with that. But and I can give you examples. But the truth is that if you centered around human capability, how do we do things differently that we couldn't do before? How would we do things in a new way? That's really what we should be aiming our regulatory activity at. Now, that doesn't mean that just because legislators know people that they can write wise tech policy. They should understand the technology, because by understanding the technology, they can get a sense of what really is possible and what is and what is not, what's contingent, what is non-contingent. But ultimately, yes, I don't think it's wise to regulate every little slice of technology as it arises, because it's going to be constantly changing.
How does ethical considerations play into this? Are scientists and technologists, are they prepared culturally? And when I say that, I mean that relative to their industry, right? Are there enough guardrails around questions of morality or ethics that are helping to guide the way these technologies, both the hardware and software, are developing?
So I just wrote a piece for a leading engineering society, IEEE, about the way about the tendency of well-meaning individuals and organizations, nonprofit and industry alike, to come up with a set of ethical principles in order to guide artificial intelligence and robotics, on the theory perhaps that this is also new and we really need a common foundation.
But first, and that doesn't exist. So that common foundation doesn't exist, and it isn't.
Is the idea, yeah. But what I found, Adora, is that oftentimes the ethical principles are things that everybody already knows. I mean, they're at a level of generality that nobody would seriously disagree with. For example, does anybody think that we shouldn't keep people safe, or that or that does anyone really think that it's okay for algorithms to be biased? Does anybody, nobody thinks these things, right? But what's really lacking, I think, is the
we'll argue about that on another panel. But
okay.
Because now that those biases and whatever have you have been brought to their attention, they're still not changing them.
Right. So exactly.
At a certain point, it becomes intentional when you now know. But I'm sorry, go ahead and finish that thought.
No, we're right on the same page. I would just say, I think ultimately it comes down to a matter of, first of all, political will. I mean, we've been so addicted to technology giving us our innovation edge, at least in the United States and in Europe and Canada and elsewhere. Is there really the political will to sort of, maybe not kill the goose that laid the golden egg, but even put any guardrails around it whatsoever? And then second of all, I think there's a lack of confidence, precisely because policymakers don't necessarily understand the technology under examination.
I think it's really hard. Let's talk briefly, if we can, because these are gargantuan issues, and they're going to be around long after we're not. And our children's children. It's just the nature of the evolution of technology, I think, is arguably the case. But what about robots and privacy? When we talk about anything from that vacuum cleaner, or you talk about the Internet of Things in your home, right, that can do these devices that can do multiple things, like Alexa or Google Home, or any of these voice activated assistants that could then have some level of machine learning and ability to record what's going on and around. I mean, the list is very long, but give us a lens on ways to think about that, and how are we doing when it comes to that idea of that data that is generated with those types of devices being encased in some level of competent privacy
I'm glad.
protections?
Yeah, I'm glad that you asked that. I mean, obviously, privacy is an incredibly important value that's much discussed today. Well, almost by definition, or at least the definition I offered earlier, robots are going to implicate privacy, right? Because they have to sense the world and they have to process and act upon it. And I've argued in my own research that robots implicate privacy chiefly in 3 ways. And the first is that they enhance the capability of surveillance. Obviously, drones make it easier to watch people. Number 2 is that if you have a robot in your home that is connected to the internet and connected to a company and so on, it gives that company and perhaps the government with a warrant access to interior spaces. So it gives you access to spaces that you didn't have before. If you have a Roomba in your home, you know, and it's connected to the internet, if you have an Echo in your home and it's connected to Amazon, right? And the third way is, to me, the most interesting, but I think the least discussed, which is that we as human beings are very poor at differentiating between real actual agents like you and I and artificial agents. And we're somewhat hardwired to react to anthropomorphic technology, such as robots or even disembodied voices, as though it were actually a person. And one of my concerns is that a third way that robots will implicate, if not privacy, then at least solitude, is by making us constantly feel like we're around something that is social and has agency. You know, that is to say, in our cars and our phones, you know, in our offices, always this agent there ready to help you and listening and talking to you as though a person were really there. If that's our built environment, you know, where are the dwindling opportunities to withdraw and to be alone and to feel but by oneself? And so that's a dimension I think is under discussed, but one that is really critical.
Why is that bad? I mean, is there some consequence, and is there some consequence of that, particularly at scale, as the world becomes more and more connected?
Yeah, I mean, I think that the literature is really clear. You know, the privacy literature, the literature in psychology and sociology. You know, we human beings need the ability to be able to withdraw, to be able to feel like we're off stage, and to put it in Alan Weston's words, you know, we need privacy and solitude to understand who we are and to try on different things. And we cannot be constantly observed. If we're constantly observed, it has costs to our self-development and actualization, our creativity. You know, for those who are interested in learning more, I would recommend, for example, the essay by Julie Cohen, What Privacy is For, and the new book by Neil Richards, which is called Why Privacy Matters, that really articulate the importance here, and refer specifically to artificial intelligence and robotics as being, as chipping away at that privacy that we really need as people.
Kay came up I'm going to ask this last question. Kay asked a really fascinating question, and I think this is a good way, I think, for us to close here. Is do you agree with Max Tegmark, the Swedish physicist, who says that autonomous weapons are the existential threat emerging from machine learning? Those soldier robots, you know, under development, are obviously quite a sight. And if it's an existential threat and the lawmakers don't have the language to sort of address it, I mean, what's the next step here in your estimation, based on where we are today?
I'm sorry that I have to disagree with Max and Elon Musk and some others. You know, I've met Max many times, and Elon Musk too. And you know, I think there's a real danger to us overemphasizing the prospect of a robot revolution and believing that they're posing an existential threat. You know, the harms of robotics and automation and artificial intelligence are much more immediate and concrete. I mean, I'm struck by, you know, one time Elon Musk I mean, and not to pick on him, but he's just a very good illustration of the issue. He got up in front of a bunch of governors. He was at the sort of, you know, the organization of all the governors in the United States, you know, the governors conference that they have. And he told them that the main threat they needed to be worried about was that robots were going to like wake up and kill us. And he said, you're not going to be worried enough about this until, he says, robots go door to door, dragging people out and killing them. And the irony, Adora, is that within just a couple of weeks of that speech, his own robot that he made, the automated self-driving Tesla, actually killed a person, right? Because the person wasn't, engaged enough, as you might imagine, because they thought the car was able to drive for him. But then there was a problem where the car didn't detect a white van against a light sky, and it cost someone their life. The idea that robots, and by the way, I should just be crystal clear that I really believe in robotics. I think it is the transformative technology of our time. And we have not talked much about this, but the upside for humanity of robots is enormous. They're capable of doing all kinds of incredibly important things and of helping us in many, many ways. But that needs to be done in a responsible and safe manner. And I think if we concentrate too much and dwell too much on their capacity to become conscious and somehow take us all out, the Terminator, I really think that we're keeping our eye off the ball and that we really should be thinking more about the immediate consequences. So I respectfully disagree that that's really the threat.
I like the way that you phrase that all. And I think, just a little bit more, and I think we can close on this. I agree with you 100%. I spent a lot of time in the emerging tech world, which is all of these new technologies, right? And especially around 3D and computer visualization and AI. And at the end of the day, there are some extraordinary applications that are life-saving. I mean, if you have machine learning and it can detect a tumor in your body based on medical imagery faster than the human eye, then that is fantastic, right? And so I think we're really not at a different point in history that we've always been with technology, that sometimes it's used for extraordinarily progressive purposes, and then sometimes it can be used for some real potentially questionable applications. So if you want to just have a closing thought about where that that balance is, and how we can chip away at addressing some of these very real concerns that we did spend most of the time discussing.
Yeah, I mean, one of the things I've noticed is that both the most ardent proponents of AI and its greatest detractors, seem to agree on one thing, which is that it's going to change everything, right? It is a transformative technology of our time,
Yeah.
Whether it's going to be all bad or all good or an existential threat or lead to some utopia. And my view is that if it's true that it's not all hype and that AI and robotics is going to change everything, then one of the things that needs to change is law and legal institutions.
Right. Yeah.
Right. And so I welcome the progress. I invite the progress. I think I can think of myriad uses of these technologies, but I think there needs to be guardrails in place. And I think that we as a collective public, as a civic body, need to be channeling the technology in the public interest as we have done in years past. And not always very well. And so, I think that's right. I think that I think the more powerful it is, the greater the need for government involvement.
I think that's true, and I should probably disclose that I'm also a lawyer, but I'm not agreeing with you because of that. But because but ultimately, in all human civilization, right? We don't live on islands by ourselves, and when we're collectively engaging in these various activities, we've got to have some guardrails, just for the betterment of, or to be responsible, as you said, to make sure that we are doing things in ways that are potentially way more beneficial than they are harmful. But obviously this conversation will continue for a very, very long time. I would encourage the audience to keep a lookout for Professor Ryan Kalo's work. He's at the University of Washington. He's a professor there. And we'll be on the lookout for your IEEE paper so we can continue to learn more as we move forward. Thank you so much for your time. It's been a tremendous pleasure.
Thanks so much for this. Great questions. I love the discussion.